Hello. We are going to look at another problem in which we will calculate the average and reactive power for a system that we have shown here. Let me read the problem. For each of the following sets of voltage and current, calculate the real or average power and the reactive power in the line between networks A and B. In each case, state whether the power flowing is from A to B or vice versa. 2. Also state whether magnetizing vars are being transferred from A to B or vice versa. So we want to know who's absorbing and who's delivering. Okay, let's take a look at A here. And our current is going into box B, and our voltage is plus minus. So it's as though we're really just looking at terminal B. But we want to know what direction things are going to. So, okay, let's start with our equations are shown here. And this is real or average power. And this is reactive power. And in both, we need to know the maximum amplitude of the voltage, which in A is 100 volts, and I sub M is 10 amps. And our phase shift for the voltage is 50 degrees, and theta sub I is 15 degrees. All right, so let's take a look at average power first. So P is equal to V sub M, which is 100, times I sub M, which is 10, over 2, cosine theta sub V, which is 50 degrees, minus theta sub I, which is 15 degrees. So P is equal to 500 cosine 35 degrees. And P is equal to 409.5 watts. And this is a positive. So if it's a positive, then that means that our power is being delivered from A to B. Or we could say that B is absorbing power, and A is delivering. Okay, now let's take a look at reactive power. Again, we use our maximum magnitude voltage, which is 100, current is 10, divided by 2, and in this case it's sine theta sub V, which is sine theta sub V is 50 degrees minus theta sub I, which is 15 degrees, and Q is equal to 500 sine 35 degrees, and Q is equal to a positive 286.79, and that is var. So since it is positive, that means that B is absorbing, so A is delivering, and our flow is A to B, and which means B is absorbing magnetizing vars. And I guess I should have said first, A is delivering. Okay, but our flow is A to B. So, and I also want to mention, just real quick, that, let's see, if we looked at where we fall here, 35 degrees falls here, so our sine would be a positive, and our cosine here would also be positive. So that checks with the values that we got. All right, let's move on to part B. So again, our V sub m is equal to 40 volts. Our I sub m is equal to 5 amps. And theta sub v is equal to minus 15 degrees. And theta sub I is equal to 60 degrees. All right, so let's find the average power first. So P is equal to 40 times 5 divided by 2 cosine theta sub v, which is minus 15, minus theta sub I, which is 60 degrees. And P is equal to 100 cosine minus 75 degrees. And let's just take a quick look. That would bring us down here, minus 75 degrees. So in this case, cosine should be positive and sine would be negative in that quadrant. All right, so P is equal to, let's plug it in the calculator, 25.88 watts. And since it's positive, then our flow of reactive power is from A to B. All right, let's take a look at reactive power. So Q is equal to 40, and actually I'm going to move this down because I've got another guy here. So 40 times 5 divided by 2 times sine of theta sub v, which is minus 15 degrees, minus theta sub I, which is 60 degrees. So Q is equal to 100 sine minus 75 degrees, and we should get a negative value, and we do. It's minus 96.59 bar. And since it's negative at these terminals, that means B is delivering magnetizing bars, and A is absorbing. So our flow should be B to A. All right, let's move on to C. All right, in this case, we've got our current is expressed in terms of sine. So let's change that to cosine. So I is equal to 10 cosine omega t plus 240 degrees minus 90 degrees. That's amps. So I is equal to 10 cosine, and we'll plug this into the calculator, omega t, 240 minus 90 should be 150 degrees, and that's amps. All right, so with that done, we can now find V sub m, which is 400 volts, I sub m, which is 10 amps, and theta sub v is plus 30 degrees, and theta sub I is plus 150 degrees. All right, so let's find our real power or average power, P. So P is equal to V sub M times V sub I, oh, I need another zero there, divided by 2 times cosine theta sub V, theta sub V, which is 30 degrees, minus theta sub I, which is 150 degrees. So P is equal to 2000 cosine minus 120 degrees. Pop that into the calculator. Well, let's take a look here first. Minus 120 degrees will get us in this quadrant. So in that quadrant 3, our cosine should be negative and our sine should be negative. So let's pop that into the calculator and we get minus 1879.39 watts. And let's see, so it's a negative, so that means that B is delivering and A is absorbing. So our flow of average power should go from B to A. All right, let's take a look at reactive power. So Q is equal to V sub M, which is 400, times I sub M, which is 10, divided by 2, times sine theta sub V, which is 30 degrees, minus theta sub I, which is 150 degrees. And Q is equal to 2000 sine minus 120 degrees. And if we pop that into the calculator, we should come up with minus 1732.05 var. All right, so that means that B is delivering magnetizing vars and A is absorbing. So our flow should be from B to A. Okay. All right, D. This time our voltage is expressed in terms of sine, so let's change that out. So voltage is equal to 200 cosine omega t plus 250 degrees minus 90 degrees. And that should bring us to V is equal to 200 cosine omega t plus 160 degrees. So our V sub M is 200 volts and our I sub M is 5 amps. Theta sub V is positive 160 degrees. Theta sub I is positive 40 degrees. So let's find our average power P. P is equal to V sub M, which is 200, times I sub M, which is 5, divided by 2, cosine theta sub V, which is 160 degrees, minus theta sub I, which is 40 degrees. So P is equal to 500 cosine 120 degrees. And let's just real quick take a look at that. 120 degrees would bring in here. So sine would be positive and cosine would be negative. So we should expect a negative number here. So P is equal to minus 250 watts. And that means that this guy is delivering average power and this guy is absorbing So our flow would be from B to A. All right, now let's take a look at reactive power. So Q is equal to V sub M, which is 200 volts, times I sub M, which is 5 amps, divided by 2, sine, and our theta sub V is 160 degrees, minus theta sub I, which is 40 degrees, and Q is equal to 500 sine 120 degrees. And we're expecting a positive number here. So Q, pop that into the calculator, is 433 var. And that is a positive number. So since it's a positive number here, then that means that B is absorbing magnetizing vars, and A is delivering magnetizing vars. Delivering. So our flow is from A to B. All right, that concludes.